Okay, let's start with a real problem. So, let's draw our circuit. So our circuit is gonna be looking like something like this. We have a generator here. Then we're gonna have a node and another node here with a resistance. And then from this node, I'm gonna have a resistance as well. Okay. Yeah, like this. And then here we're gonna have a node and another resistance here, and we'll get all the way to here. And then down here we're gonna have, guess what? A resistance. um, and then down here again, a resistance. And then all the way back to the generator. So this is gonna be my generator, plus minus E. It's gonna be my resistance R1, my resistance R2, my resistance R. This is gonna be R, this is gonna be R as well. This is gonna be my point A. This is my point B. This is my point C. And this one in red is gonna be my I. So the problem is actually saying for the circuit below, we have E equal to 12 volts, R1 equal to 1 ohm, R2 equal to 3 ohm, and then R3 equal to 3 ohm. Find I. Okay, so first thing first, this circuit is not what, it's, yeah, we can say, okay, so basically the current is flowing here, it's gonna get down here, it's gonna go here, it's gonna get down here, one here is gonna go here, it's gonna then go here, and from here it's gonna go down here, and from here is gonna go back here, and then back to the generator. And then we could try to apply Kirchhoff law on each and every end, but that's not, that's, we have to, we can simplify this. We can actually simplify the circuit, and simplifying circuits is actually very, very important because it's going to allow you to have a better understanding of circuit, and also whenever you're going to calculate things, things are going to be easier. So in this case, we can say, okay, hold on a second, I know what this is, this, and I also know what this is. Okay. But in particular, we know what these three resistances called are. When you see those resistances put in this way, so 1, 2, and 3, is as if they were forming a triangle, like so, like this is the base, this is the hypotenuse, and so on. But it's like a triangle. So as you as basically the definition, this is a triangle. Okay. Sometimes they also call this delta, because delta, the delta symbol is just this. It's just like a triangle. So sometimes they call this delta, but I'm just gonna call it triangle or delta. It's fine either way. So I'm just gonna call it triangle. I like triangles. Yeah, they're fine. They're fine. Anyway, so this is a triangle. So we can actually say that we can I'm just gonna say we can simplify the circuit by transforming the triangle, so the delta, okay, for those of you who like delta, made by the resistances R into the equivalent star. Okay, so we have a triangle and we're going to turn it into a star. And I know what you're saying. You're basically saying, okay, hold on a second. This is a triangle, so this is a delta. What is a star? A star actually is, I'm just going to say, if this is a delta, so a triangle, a star is like so. Okay, this is the star and this is the delta or triangle. Okay, so this is the delta or triangle, this is the star. And we're basically going to turn the triangle into a star. You may not, you know, you're gonna see it. You're gonna see it. You're gonna see what I mean, in just a little bit. So basically, let's do this. Let's turn this delta, this triangle, into a star. So in order to do this, let's draw our circuit from scratch again. So this is gonna be our power supply, and then we're gonna have this node, just like before, and this other, and we're gonna have the resistance here, and here we're gonna have resistance, and then we're gonna have this resistance, and again here, and then here we're gonna have a resistance. So this is my point C. This is my point A, this is my point B. I'm gonna be looking for VAB. This is a minus. This is gonna be my R1, R2. I'm gonna call this RA and RA, and here I'm gonna have my current I1 and I2. And this one here is going to be my resistance RA. Okay. This one I'm going to call it IT. It's going to be clear in a little bit. It's still going to be my power supply. Okay, there we go. So basically here now we have the equivalent circuit, but we just transform this delta, this triangle, into a star. You know, this is a star. Okay. So, and I wrote RA, RA. So now, why would I do this? Well, because calculation is going to be better this way. So now, the reason why I put RA here is that I'm gonna actually have to find RA. So RA is actually going to be given by r over 3. So r over 3, we basically said that those were going to be 3. So it's like saying 3 over 3, those two cancel, 1 ohm. Okay, so those RA are going to be 1 ohm. Now, I want to find RT. So what is RT? Well, let's say this. Let's say I want to find the resistance RT as the generator sees it. Okay, so basically I'm gonna now I want to find RT, but just as this generator is saying it. So the R total. Okay, so the total resistance. So in order to do this, I'm going to introduce something new here as well. I'm going to have R1 plus RA, okay, so those two. And notice what I'm going to do here. Those two are in series, and those two are in series, but those two are in parallel with those other two. So I'm going to write R1 plus RA, those two are in series. Then those two are in parallel with R2 plus RA, which are in series between them, plus RA. So what does it mean series and parallel? So basically, if you have two resistances which are like this, okay, so they are attached to the same in this case they're on the same node and attached on the same end, so they share only this one, then they're going to be in series. If they are like, I don't know, like this and then like this, then they're going to be in parallel, because, you know, perhaps we have something else here, like the generator, no, not the generator, but anyway, those two are going to be in parallel. No, it's not the best explanation of all, but I really want to be quick here. So basically, I'm going to have R2 plus RA. So R2 plus RA. So those two are in series. Those two are in series. And those two are in parallel with those two. Okay. So I'm going to have plus RA, which is this teeny tiny one. No, it's not teeny tiny. It's 1 ohm anyway. So, but anyway. Okay, so, well, rather this lonely one, not tiny one. Anyway, so let's do this. And I'm also going to explain what I mean by this. Yeah, I said parallel because, in fact, they are in parallel, but just going to explain what I mean by this. So basically, what do we have? Well, we have RT equal to R1. What is R1? Well, R1, we know it. I forgot to write them right next to those. My fault. This is 1 ohm. R2 is 3 ohm. RA, oh well, we found all of this, so it's going to be 1 ohm, 1 ohm, and 1 ohm. There we go. Okay, so we have R1, which is 1 ohm, plus RA, which is 1 ohm, in parallel with R2, which is 3, okay, plus RA, which is 1. All plus RA, which is 1. Okay, so now we have RT equals to 1 plus 1 is 2, in parallel with 3 plus 1 is 4, all plus 1. Okay, here is the thing. Okay. Now, I know what you're thinking. You're saying, what does it mean to have 2 in parallel with 4 and then plus 1? I'm just gonna check my algebra, but I'm thinking I'm right. 2 yeah. So basically, if you have 2 in parallel with 4, this basically means that you have 2 times 4 over 2 plus 4. So having this symbol here, so in parallel, literally just means doing like multiplying those two numbers and then dividing them by the sum of these two numbers. And the reason why I was doing this was I was basically checking with my calculator whether I got it right, and yeah, I got it right. But you know, it was fractionary, so it's it's a little bit complicated because I wanted to have it with not in a fraction because we're doing circuit. But anyway, so yeah, when you have two numbers in parallel, you have to multiply, so it's 2 times 4 divided by their sum. Always, always, always. You have to multiply them and then divide by their sum. So in this case, RT is actually going to be equal to, well, 4 times 2, 8. And 4 plus 2, which is 6. Okay. Then we have everything plus 1. Why use the calculator? Well, because I was actually doing 8 over 6, which is 1.3333. And so I'm just going to say, okay, this is 1.33 plus 1, which is going to give me my RT, which is 2.33 ohm, of course. Never forget ohm here. Okay. So this is my total resistance. So this whole thing here, okay? Okay, we're slowly getting here, getting there. So now what I'm going to do, well, is to get a new piece of paper, first of all. But no, seriously, what I'm going to do is to say, okay, now I want to find the current IT, so I total, of the generator. So this is basically the reason why I wrote IT here, right next to the generator. I want to find the total current that the generator is basically producing, you know, the current that is flowing. In order to do that is very, very simple, because, you know, we have now found the total resistance, so we can just say, okay, I want to find the total current, no problem. The total current IT is actually going to be E, so the value of my generator, over RT, the total resistance. So basically, we have 12 volts. Was it 12 volts? Yeah, I made it 12 volts. Dang, I always have to write 12 volt next to the circuit. I always do that. I don't know why I don't do it while I'm recording. I don't know. Whenever I'm on my own, I always do that. I don't know why I'm not doing it here right now. Like I'm recording, I'm supposed to do everything, very, very precise and step by step, but instead I'm not. Well, everything is fine anyway, but still. So basically, we have the I total is the value of our generator, so 12 volts, over the total resistance, which we have just found is 2.33. And for the mathematicians among you, yeah, we do approximate numbers. Sorry about that. So basically over 2.33. And I'm just going to use the calculator because I'm lazy and I cannot do this calc. So 12 divided by 2.33, yeah, it's 5.15. So I'm just going to write 5.15 amps. Thanks, Casio. Goodbye. So yeah, this is actually going to be 5.15 amps. So the IT, the total current is 5.15 amps. Now we're getting there. Now I'm just going to apply the rule of the current partitioner in order to find the two currents I1 and I2. So how do I find I1 and I2? Let's start with I1, okay? I1. So I1, so let's find I1. So basically I1 is actually the IT. So it's this is I1, this is the current flowing here, and we are gonna have another current flowing here. I know what you're thinking, basically thinking, okay, but they're gonna be the same current. No, they're not gonna be the same current because we have different resistances here and different resistances here. So the current is definitely gonna be different. They're gonna add up together once they get here and go back here. So we know that I1 is going to be a subset of I of t, and I2 is going to be a subset of I of t. And those two added together are going to be exactly I of t. But we have to find them individually. So I1, that's going to be I of t, as it's a subset of I of t, times, and we're going to have R2 plus RA, so R2 plus RA over R2 plus RA, I'm just going to write them like this, just to make everything clear, plus R1 plus RA. Okay, so basically, as you can see from here, we're going to have R2 plus RA, okay, R2 plus RA over R2 plus RA plus R1 plus RA, okay? This is gonna give me, times, of course, I of t. This is gonna give me my I1. So if we just substitute those values, get that I1 is actually equal to I of t, which we have just found, so it's 5.15 amps, times, well, R2 is 3, plus RA is 1, and those two, R2 is going to be 3, plus RA is going to be 1, plus R1, which was 1, and still is 1, plus RA, which is also 1. So we have this very different, very difficult calc to make. I'm just joking, of course. So we have 5.15 times, well, 3 plus 1 is 4, and 3 plus 1 plus 1 plus 1 is actually 6. So 4 and 6 we can get 2 and 3 out of them as we simplify them. So I1 is actually going to be 5.15 times 2 over 3. So if we do this in our calculator, we're just going to get that I1 is equal to 5.15 times 2 over 3. Yeah, 3.43. So we get 3.43 amps. Now let's find I2. So I2 is going to be different. And those two added together are going to give us back I of t. So I2 is actually going to be IT as is a subset of I of t times, well, in this case, we're going to have R1 plus RA over R1 plus RA plus R2 plus RA. So we're going to have R1 plus RA over R1 plus RA plus R2 plus RA. So if we substitute, we get that I2 is going to be equal to I of t, so 5.15 times R1, which is 1, plus RA, which is also 1, over R1, which is 1, RA, which is also 1 again, plus R2, which was and still is 3, plus RA, which is still 1. So we get I2 is actually equal to 5.15 times, well, we get 2 over 6, because yeah, 1 plus 1 is 2, 3 plus 1 is 4, plus 1 is 5, plus 1 is 6. So those two actually get down to 1/3, as I can simplify those two guys. So I get I2 is 5.15 over 3. So if I just use the calculator again, I get that 5.15 over 3 is actually 1.71. Now there is a 6, I'm gonna go with 72. So I'm gonna go with 1.72 amps. Yeah, so we're almost there. Because you know what we're trying to find now is the voltage here, so VAB. So we're really almost there. We're almost done. So now what I'm gonna do is that I'm getting to the interesting part. Well, all this was interesting already. It was kind of nice, to be fair. But anyway, we're getting to the very interesting part. Now we're going to apply the Kirchhoff voltage rule to this 4 by R1 and R2. Okay, I'm just going to apply the Kirchhoff voltage rule. And I'm going to say that VAB, okay, so I'm going to apply the Kirchhoff voltage law. Yeah, it's not a rule, it's a law. Okay, so VAB plus R1 times I1 minus R2 times I2 is going to be equal to 0, which I can get VAB equal to negative R1 times I1 plus R2 times I2, which also gives me VAB equal to, I'm just gonna put number in here, so negative 1 times 3.43, which was our I1, plus 3 times 1.72, which is our I2. So now I'm gonna say VAB is gonna be equal to, well, this Y1, well, it's still gonna be negative 3.43, and this other one by 3 is roughly 5.16, I think. And then if we add those two together, VAB is it's gonna be, well, negative 1.73, positive 1.73. So now that I have found everything, now I have VAB. I just have to find what the problem was asking for. So basically the current that the problem was asking me. So the current here. In order to do that, I'm just gonna say, okay, now my current I, and I'm just gonna call it I, is gonna be VAB, so the voltage between those two ends, okay, so VAB, which are just those two, A and B, okay, over the resistance R, which we have here. And we have everything now, because I can say, okay, fair enough, I, therefore, is just going to be 1.73 divided by R, which is the basically the resistance that we have there. So 1.73 divided by R, which was 3, is going to be, well, I've already done this here, 0.57, so I'm just gonna 0.666, so I'm just gonna say, okay, I is gonna be 0.58 amps. That's it. That's our current. Done. Was it that bad? I don't think so. Well, you really gotta get your mind around, wrap your mind around. It's not easy the very first time you do it, but you're gonna get used to this. Honestly, I promise you, you will.